Hi YouTube. So in one of the previous videos, I think it was the eigenvalue video, we covered how to find an eigenvalue. So this is the matrix. We do that A minus lambda identity matrix function, whatever. We find the determinant and set that determinant to 0. And we found that these eigenvalues are equal to 1 and 6, which you can confirm. But so what? So you can use these eigenvalues to find the eigenvectors of the original matrix. So in order to find the eigenvector, we can subtract these eigenvalues from the A and D entry. So let's do that. So if we subtract 1 from the A and D entry, we get 1, 2, 2, and 4. And if we subtract 6 from the A and D entry, we get -4, -1, 2, and 2. And then what we can do with these numbers is find the ratio between entry B and entry A, and then add a negative sign to one of the numbers. So the ratio would be 2 to 1. So 2 goes on top, 1 goes on bottom. Then we add a negative sign to either of these numbers. It doesn't really matter. And then we can do the same for here. So we have 2 to 4. But remember, the ratio is simplified. So 1, 2 is our simplified form of the ratio. So that is going to be our eigenvectors for each of these. And then an interesting property of eigenvectors is that when you multiply the eigenvectors with the original matrix, we get a perfect multiple of that eigenvector that we multiplied with that matrix. So let's try that out. 2, 2, 2, 5, 2, -1. 4, -2, then 2, see, that's 4, -5. And our product is exactly that, which is a multiple of 2, -1. It's just multiplying by 1. Well, we can turn this matrix into a system of equations, of differential equations. So we can say that A is equal to x prime, which is equal to 2, 2, 2, 5, x. So basically what this is saying is we have x1 prime equal to, well, let's see, 2x1 plus 2x2. And then we have x2 prime equal to 2x1 plus 5x2. That's basically the meaning of this differential equation. So essentially this x prime is just x1 prime, x2 prime. And this x is x1, x2. So what we can do with these eigenvectors and eigenvalues is we can have a solution of this x. And it actually comes in a pretty simple form. Basically it's C1, this eigenvector, 2, -1. And then we have e to the t, 1 times t, the eigenvalue times t as the power, plus C2, second eigenvector, 1, 2, e to the 6t, the second eigenvalue to that power. And that's basically the solution. So let's try a practice problem. Let's say we have x prime equals to 1, 1, 1, 3 x. Well, we can try to find its eigenvectors and its eigenvalues. So let's subtract lambda from A and D. So we have to find its determinant. That is equal to 1 minus lambda times 3 minus lambda minus 1. Set that to 0. And then we can multiply it out. So that's minus 4 lambda plus 3 minus 1. So we have this quadratic equation. And then we can use the quadratic formula, which I hope you all know. So our two eigenvalues are 2 plus root 2 and 2 minus root 2. So we can subtract this from A to find our eigenvectors. So let's start with 2 plus root 2. So if we subtract 2 plus root 2, we get minus 1 minus root 2, 1, 1, 1 minus root 2. And then for a second eigenvalue, we get 1 plus negative 1 plus root 2, 1, 1, 1 plus root 2. And then we can find our eigenvectors by finding the ratio. In this case, it's just 1, 1 plus root 2. And then here we have 1, 1 minus root 2. So after that, we can just plug it into that equation. So we have x is equal to C1, of course, which is just an arbitrary constant. You can plug anything into there and it'll still be a solution. Then we have e to the 2 plus root 2 t power plus 1 minus root 2 e to the 2 minus root 2 t power. Oh, don't forget the C2. That's our solution.